section 7.3, which is the SourceFreeRL circuit. Procedure-wise, it's really similar to the SourceFreeRC circuit that you did in the last section. So we have this circuit, and again, some switch opens at time t equals 0. I don't have my I naught in there. There we go. And if I look over here and do a KVL, I have VL plus VR equals 0. Excuse me, for time t greater than equal to 0. Well, for VL, the voltage across an inductor, I know from section 6 that that's L di dt. VR, voltage across a resistor, Ohm's law, is IR. So I can write this like that. And if I want to rearrange it a little bit, di dt plus R over Li equals 0. There's my first order differential equation. Go ahead and move this over to the other side and then integrate. So I'm going to integrate. I'm going to get ln from some initial current to I of t is equal to minus RTL 0 to t. And obviously solving that down, you can follow along in your book. That's just calculus stuff. We get I of t equals I naught e to the minus t over tau, for t greater than equal to 0, where our tau is L over R. So you notice this is very similar to what we got in section 7.2, again for the RC circuit. Difference being now we're talking about current because we're talking about an inductor. So when you think inductor, think current. You think capacitor, think voltage. And our tau is L over R. So our steps in finding these equations is very similar, again, to section 7.3. First thing you want to do is find your initial current, find your I naught. Second step, find your tau. And our third step is put it in an equation. And that is all there is to these problems. They're really not difficult, so don't make them harder than they need to be. And then obviously once we have our I of t, we can find these voltages, because we can use VL equals L di dt. So if we take the integral with respect to t of this I of t, then I'll get our VL. And if we do the math on that, again, it's in your book, and it's just calculus, which hopefully you can do, or you wouldn't be taking this class. We get this, and for our VR, V equals IR. So we just have this equation times R. Sorry, that's a plus. And I have that these are the same except opposite signs, which means this holds true, my KVL, so I know I've done something correctly. Or we can write that as VL is equal to minus VR, or the other way around, right? Put the minus sign on whichever side you want that equals. All right, so let's